anything to you. Visualizing 1 billion is tough, so I've made a separate video to help you with that as well. Centauri. At the speed of light, it would still take us 4.2 years to reach it. If you've ever heard of the Voyager spacecraft, the fastness of it all. Sometimes it's fun to do before pulling things back into our reality here on Earth. Just for a little perspective, at a speed of 5 million light years every second. Every little light you see us passing right now is a galaxy, each with billions of stars of their own, which all have the potential to have planets of their own. And there are billions of galaxies in our observable universe. From what we can see, the observable universe is 16 billion light years across. Let's see what comes next.
They soon observed that some stars were not fixed, but moved in the sky from night to night. They called these stars the Wanderers.
I'm going to go for another effect. This effect is called twins.
At the center of our solar system is the Sun, binding the planets with its gravitational pull. From our viewpoint on Earth, the Sun appears small in the sky, but in reality, it dwarfs even Jupiter, the largest planet in the solar system. The distance from the Sun to the small worlds traveling around it are vast. Light from the Sun takes 8 minutes to reach Earth, and nearly a day to reach the farthest known bodies. Starting with sun-baked Mercury and traveling to the remotest outskirts, where small, icy bodies move with only the faintest. Mercury, the closest planet to the Sun, is also the smallest terrestrial planet. It orbits so swiftly that its year lasts only 88 Earth days. Unbroken layer of sulfuric acid clouds, part of the planet's thick, smothering atmosphere of carbon dioxide, a potent greenhouse gas which traps the Sun's heat and turns the surface into a desert with temperatures of 870 degrees. The surface is a nearly uninterrupted expanse of rolling volcanic plains that dominate the landscape. In the 1970s and 80s, Soviet landers survived on the rock-strewn surface of Venus, just long enough to give us our first glimpses of the planet close up. The Earth is the one body in the solar system where water can exist stably as a gas, liquid, and solid. And this has made all the difference. Vast oceans dominate the planet. Polar caps and sea ice grow and shrink with the seasons. Earth, the only known haven of life in our solar system. Evidence of the teeming bustle of life in the Grand Canyon. It has the most Earth-like environment of any other planet, but with its tenuous atmosphere, frigid temperatures, and radiation-drenched surface, it still cannot support Earth-like life. Thin as it is, the Martian atmosphere is incredibly dynamic, with seasons and polar caps that grow and shrink. Often large dust storms begin to swirl in the deeper basins. Sometimes these grow into massive globe-encircling maelstroms.
The Asteroid Belt.
Beyond Mars is a vast region of space known as the main asteroid belt. A graveyard of millions of rocky pieces of shattered young planets and bodies that never got a chance to grow.
You know what?
The region is long gone. So what happened here? Why didn't these asteroids ever come together to form a planet? What was responsible for throwing most of the material out of the asteroid belt and causing all of these massive collisions? Next, we move to beautiful Saturn. Saturn's atmosphere at first appears to be serene, but this planet, too, hides powerful storms and winds. But Saturn's most obvious, most majestic feature is the extensive system of rings, a graceful collection of ice, rocks, and dust, shepherded into place by small moons. Images of the rings reveal lovely scallops and swirls caused by the moonlets embedded within. Saturn is also surrounded by more than 60 diverse moons, including cloudy Titan, which has an atmosphere of thick hydrocarbon smog covering an icy surface dotted with methane lakes, sand dunes, and icy volcanoes. Another example is odd Iapetus, with its stark contrast of extremely dark and very white surface features. Deep in Saturn's gravitational thrall, pushed and pulled by strong tides that help activate geysers. First of the ice giants, Uranus receives 400 times less sunlight than Earth, and its clouds lie deep in the atmosphere, masking the planet's turbulence and giving it a calm blue color. But Uranus is special. The planet lies nearly on its side, and this extreme tilt gives rise to seasons that last nearly 28 of Earth's years. As previously dark areas of the planet receive sunlight and begin to warm, powerful storms build in the atmosphere. Like the other giant planets, Uranus has many moons and faint rings, few of which have been seen close to 6.
Voyager 2.
The final giant planet is Neptune, the other blue planet. It is also a stormy planet, though it is even colder than Uranus, and the seasons are not as extreme. Like all the giant planets, Neptune has faint rings, and it radiates more heat than it receives from the Triton, likely captured by Neptune when passing too near, has a surface marked with nitrogen geysers that form a thin atmosphere. Who knows what other surprises await on the moons of Neptune? Between planets lies a region with many dark and icy objects, called the Kuiper Belt. Some of these bodies, classified as a planet, may have a thin atmosphere that freezes to the surface during winter, and has at least 4 moons, including Charon, Nix, and Hydra. Far beyond the Kuiper Belt is the Oort Cloud, a vast region that encloses the entire solar system. Packed as it is with all these marvels, our solar system is not unique. Throughout the Milky Way galaxy, many stars have been found with planetary systems of their own, filled with exotic new planets. Planets bigger than Jupiter, and yet closer to their stars than Mercury is to our Sun.
Hey, thanks for watching a tour through our solar system. Original hoster that I reviewed. Have a wonderful and blessed day.